Well, hello everyone, and welcome to our series on our Lakehouse Labs by Blueprint. We have been running a couple of these virtual workshops on Wednesdays at 12 o'clock Pacific time, and we're just so thankful if you are joining us live today. My name is Ruthie Senanaika, and I work with Blueprint on the marketing team. And I love putting on these events because I see some really great engagement, and so we want this to be, interactive. So if you have questions, please add them to the comments. Our awesome host today is Adrian, and he will be answering all the questions toward the end. So if you have questions, just keep adding them into the comments, and we'll be sure to answer them as we go. But we do have an awesome lineup of different types of webinars, workshops, demos lined up. So check out our website, bpcs.com, to learn more about these events. We have a really cool expo coming up on October 3rd. You don't want to miss that. So be sure to sign up and register for that as well. I will be passing it along to Adrian now to give us a little bit more information on the topic and hop right into the content.
All right, sounds good. Thank you, Ruthie. So, as she said, we'll jump right in. So, welcome everyone. This will be the unified AI presentation in Databricks with Blueprint. I'm Adrian Tullock, and I will be your conductor for today's session. So, we're going to be covering everything in MLOps from pulling in the data set at the beginning of the process into profiling that information, going through to creating models from it, and then monitoring it long term to ensure that your models continue to bring value to your organization. Now, I am Adrian Tullock, data scientist with Blueprint. I've been in the industry for about a little over 10 years now, and I've jumped around different areas of the industries, solving problems in healthcare, banking, things like that. A lot of different spaces, actually. But if this is a whole new platform to you, or if you've made our previous workshops, some of this content may be familiar, but there's been some changes to make sure if you've been with us before, you continue to get benefits from attending these sessions. So mostly we've added some content around Unity Catalog, which is a popular thing inside Databricks right now. So there are some changes to your process you have to implement to make sure everything is still compliant and working. And we'll kind of jump in and out of those differences with Databricks Workspace as we're going along. So without further ado, we'll go ahead and jump right in. So the first thing we're going to want to cover, once again, for those of you who are new, is what exactly ML Ops is. So some of you may be familiar with DevOps, which is the process of moving your code and applications in software engineering from development into production and getting those things live for your customers. Machine learning operations is very similar, but it's for the process of doing everything with machine learning models. And so there is context for your actual models, the code that generates them, and the data that goes into making your models useful as well. So it's a bit more complex in some instances than when it comes to DevOps. So you have two images shown here above, and they kind of help you understand at a high level what you need to know about machine learning operations. So MLOps, I would say, is more of a cycle than a life cycle. And so as you'll see in that very first image, you'll have the EDA, it circles around into an infinite symbol, and you'll get around to the monitoring phase at the end of MLOps. So as your data continues to evolve, as your business continues to operate in an ever-changing world, your data could change. The scenario in which your model operates could change, right? And that will kick off reasons for your models to evolve and continue this process over and over again, so long as you continue to operate within this space. So it's more of a set of guidelines than being very prescriptive, because the maturity of your organization would also depend on how far you take each individual step. Now, in lieu of those steps, in general, you're going to follow a lot of the same processes in understanding your data. That will be your EDA phase, and then consuming that to generate features that will go into your machine learning models, which you will then train to determine your deployment patterns and such before putting them out for inferences. And then, if you're mature enough, getting to the phase of automatically retraining these things with webhooks and triggers and things like that within the environment of Databricks itself. So we have some best practices here, but as we go through this process, you may find that your organization is in different places, and so not every best practice is going to be prescriptive. You make the adjustments where you can and where you need to. Now, that is essentially what MLOps is, but why invest in getting MLOps integrated into your organization? Because it will take time and dedication and effort, but you're essentially gaining efficiency and structure within your environments to get your machine learning models developed in a clean environment and then to production. So similarly, as we mentioned before with DevOps, it helps increase the speed in which things gets out, keeps everything organized, it makes testing easier for your developers, etc., etc. Sorry about that. Get a quick sip of water. So we've covered the why. Now, to get rolling with doing the actual process, we'll need to identify what problem we are trying to solve today. So we're going to be doing a classification algorithm, and it's going to be looking at data that breaks out how different titles signify if something is an article or if it's an advertisement, which can have wide use applications for news streams, email inboxes, things of that nature. And the idea is to have this model be able to train on the data, understand what is an article versus an advertisement, and then tell us which one it is or classify which one it is in this scenario so that we won't have to do it ourselves and wherever we decide to implement this. So we're going to go ahead and move ahead. So as we mentioned before, the first thing anyone a data scientist is going to want to do when getting your model ready is understand the data that they're going to be dealing with. So you may have questions about, do we have enough data to do a model, right? Are there going to be quality issues with the data that we'll need to address? Do we have features that we can use? Do we have features that we're going to need to engineer? And specific to classification, as we'll be dealing with, are there class imbalances? All of the things you want to be able to discover ahead of time so that you can know potentially if the data you have is not even suitable for modeling, thereby saving you a lot of time. But if it is, then the first thing you want to do is get a profile of your data. And as you can see, we're pulling our data in here. Now, Databricks itself will have its own built-in profiling tool that once you've consumed the data frame, it can spit out your data's profile broken down by its data types very quickly. Doesn't take very long to do this. However, depending on the use case that you're dealing with, it could be more or less useful for your scenario. So to kind of give you a quick understanding of the scenario that we're dealing with here, as mentioned before, we're having word data, different parts of speech items are tagged, where it sits somewhere within the title of it, and other things of that nature. So knowing that a lot of our features are going to be numerical, the profile that Databricks uses has quantified a lot of those part of speech features as integers. And that breaks down in how it's going to show our profiling. So we'll remove those, show the other things that it's profiling. And given that we're working with this type of data that'll use NLP processing, not so much just numbers, things you'll see more in retail and those type of settings, this profile isn't the best fit for us. So in those scenarios, you may want to use a different profiler, especially if it fits within the standardized profiling practices of your organization. So in the particular instance we are at, the profile we will use is specifically going to use Delta tables within Databricks to store the information and then retrieve that information as well. Now, since we just noticed in the previous profiler that one of our features that are categorical are being processed as integers, we may want to change those to Booleans to change how we get that information profiled, thereby giving us more valuable information. And this tool gives us the ability to do just that, using this line of code here and incorporating that into these lines of code to make sure it follows those instructions. So with our chosen in-house built tool, we will process with these two lines of code, and then we want to get into the actual profile itself. So in general, kind of stepping back just a little bit, when you perform an EDA, at bare minimum, you want to be able to have visualizations and summary statistics available for the profile, and you want these steps to be as easily reproducible as possible. And Databricks does offer tools to help us with both of those. So we've just looked at their profiler. We've built one that also leverages Delta tables, so still getting benefits from the environment there. and visualizations we're going to be coming up on just a little bit shortly. But in understanding what the tool can help us get from the profile that we just ran, we have these tables that'll give us our summary statistics and break things down. And to summarize those, we've kind of got a cell here describing what we were able to find. So we're normally working with about 800,000 rows, 20,000 distinct words. We're performing some NLP, so we're going to limitize those words to kind of pull more common words together. We'll be left with 16,000 unique ways there. We see that nouns occupy the gist, I should say, the heavier portion of our data set, and interjections occupy the least. And given that we're working with a high number of rows, we can kind of foresee that interjections would be a highly skewed column when we get to later profiling steps. So moving down to where we can see some of our visualizations, we see for the different parts of speech that we have, categorizing them with articles versus advertisements, symbols and numerals are more associated or correlated with ads, as opposed to pronouns, which are much more highly correlated with actual articles. And this visualization helps break that down for us. And all these were generated by simply showing our data frame and then building these visualizations within Databricks. So you can build bar charts, rows of circle charts like here, even something as far as word clouds. We can get these type of things generated as well for a high level and even low level number of words. So that'll take care of some information for our data. We can even do an analysis on our metadata to help us understand what we're dealing with as far as potential test train splits. So we can see that the gist of our data, all of it running from November 2022 into June of this year, a lot of it sits between November and February. And so if we at all care to break out our training and testing, by dates, then we can understand somewhere around February, March might make a good stopping point to ensure we're capturing at least 60 or 70 or so percent of our data in the actual training. So I don't think too much hits here from the Unity catalog. So we'll jump on to the next one because I think that may be where we first have to encounter some differences in the process. So now that we have our data set in place, we've looked at it, we've profiled it. Within the sphere of Databricks, we want to create a separate area to where the features that we actually want to do our machine learning on will be stored. And you will implement those in Databricks Feature Store. So we will put data there here, but we will cover Databricks Feature Store itself in larger context, a few more notebooks down. So once again, we're looking at our data, should be a little familiar by now, but not everything here is going to be useful for us when it comes to modeling. So small transformation here, we're going to drop certain columns. All of this is being done in Spark with Spark data frames. And once we have those set of transformations done, as simple as complex as you may or may not want them to be, we will use this code here to create our Databricks feature store. Now, the difference between operating within traditional Databricks or workspace Databricks now with operating within Unity Catalog, in practice, the biggest change for most of your developers will be adding the catalog name, prepending that to the front of all of your table names or your views or your feature stores, etc. So we've already created the catalog, which for us will be called Unified AI. You'll notice that in the widget up here, and that will be seen continuously throughout the rest of the slides, or I should say the pages. And our feature store name, which will include the actual schema/database name, and then the table that we're going to create. So to create our feature store, we're going to instantiate the client here. And all we need to create our feature store is to give it a name, identify the primary keys and the schema, and of course, pass it the data set that will hold the data that we actually want to perform our operations on. And that will store that in a table for us. And a feature store will hold the data and all the column information that we're going to need for featureization later. So just to give a little more context to the Unity catalog aspect of it, this is meant to help simplify what was just explained a second ago. So if you're operating within vanilla Databricks, everything used to operate within the Hive metastore, which was parallel with the catalog layer of the Unity catalog object model. So to simplify it, if you're working within Unity catalog, if the answer to that question is no, then typically you would supply a schema name and a table name, And when that was created, Hive and Metastore would be your assumed catalog level object layer. Once you're within Unity Catalog, you are now supplying that catalog name. You create your tables, and this is where your objects will be located. So we just created our feature store, which is going to be under a separate schema from our data. And this is what the overall catalog explorer will look like. So anything you do in Unity catalog, most of what you will find will be present in the catalog explorer, versus the UI where a lot of other things were. They have actually been moved here to keep everything in compliance, which will help make sure that the right people have permissions to certain things, et cetera, et cetera. So we have our unified AI catalog here. The profiles that we generated in the last notebook are going to be here, and each individual table here is the type of summary that we care about. Our data sets are stored under this data schema. This is the feature store schema that we just created, and the feature store tables are here. And in practice, we'll be putting models also as well when we create them in their own schema. Rationales for that are so that if we have anything that's going to monitor data of a specific model, if we're going to generate predictions of a specific model, anything we're going to track there, we want the data for those to be in a schema here, separated away from our data, which other analysts or other users could be using, or our feature store, which can come and go as we create them and delete them and evolve our models. So, see no questions. So we'll continue moving on. So the feature we want to talk about next, we've created a feature store where the data we want to train exists. Within Databricks, if you're not a trained data scientist, you are not prohibited from being able to practice some type of machine learning and get that rolling. So this tool, AutoML, that they provided does help lower the skill barrier a bit to get machine learning going. However, it does not, I believe, eliminate the need for a properly trained data scientist to be able to optimize what you get out of it. So let's kind of dive in and see what I'm talking about. So as we mentioned before, AutoML helps you automatically train and create models with your data, and it operates within three categories. So you provided your data set, you decide if you're going to do a classification, regression, or forecasting type of problem. You make a few adjustments to how you want it to function, and it pretty much takes the reins from there. So first thing to note is if you're doing anything within an environment such as Databricks, you'll need to have an active cluster running. And to perform machine learning, including in AutoML, the cluster you run has to have a machine learning runtime. So when you're creating your clusters, be sure that you see ML in your cluster name to know that it is compatible with running machine learning. Once you do that within your environment, you can come up here to New, go to AutoML experiment, and from there it should open up a window very similar to this, and this is where you will do all of your setup to make sure AutoML is going to run for you. So those three sections that we're going to make adjustments to are going to be your experiment configurations, your advanced configuration space, and your schema. So we're going to cover each one of those. So once you have your cluster running, this is our RML cluster here. Your experiment configuration is where you adjust the type of classification problem for us, but the type of ML problem you want to solve, where you're going to be pulling your data set from. We're doing classification, so we want advertisement or article to be our prediction target, and that is circled there in blue. Now, further down in the optional advanced configuration section, um, if you're familiar with the different type of metrics you care about, you can choose which one you want to use. We're using recall, but precision, accuracy, maybe other things are all there as well. The frameworks that you care about, and the timeout time. So it defaults to 2 hours, but if the system sees that it continues to try to train your models, it's not making enough progress, it will go ahead and shut down early for you to save you some compute cost. And we're labeling our model here. Now, the last section will be the schema. So here is where you can choose which features you do or do not want to include from your feature store or data table should you choose to use it to run your machine learning models. We don't care about the ID here. Read date we're using to do our training splits. And this is going to be our prediction column, these boxed out here in orange. Now, for the rest of your training data columns that you decide to use, you can confirm with Databricks AutoML which features you want to impute values for. So it can tell it which functions to use or let it automatically decide what it wants to do. We did notice in our profiling that we do not have any data gaps, so we really don't need to do the imputation, but it's nice to know that it's there to catch us in case we did not catch those gaps in our data cleaning. So once your 2 hours or less have run and you've kicked off that AutoML process, when it's finished, it will give you a result screen. And we're going to break down the sections that it shows you there. So the primary two, I guess, artifacts that you will get from it are a notebook, which goes to the data exploration to help you understand the data from its side of things, and then the best trained notebook that it was able to find based on your evaluation criteria. Now, it should generate multiple. So if you find that the best model chosen by AutoML is not the one you prefer, you can come down to the table section just below, use these metrics or tags, whatever you decide to use to filter what you want to get at, and find the one that speaks to you. If the field models do not offer you, uh, what you're looking for specifically. So it will generate a notebook for each one of these models as well. So you can also go there and make changes. And we will see a little bit of that in the next couple of pages. Now, along with that overview, it will also provide you with a warning section. So this warning section will tell you, hey, we caught these things. They may be worth you taking a look at the models that we're generating. And we can actually compare some of these with the exploratory analysis that we did earlier to evaluate how good is AutoML compared to actually having a trained data scientist work these things. So we're going to make sure we poke some holes where we need to. So we're going to pay special attention to these three warnings here. So it's going to note that the parts of speech were looked at as, what did it say here, categoricals. That'll be interesting when we get to the profile. I'll bring that up at the time we get to it. To give it some credit, though, it did pick up on lemmatized word being a word column. It's a string. It cannot run machine learning on strings. Math needs numbers. And so it caught on to that for us and transformed that via hashing into numbers so it can understand it. That's a credit to it that it caught that instead of just crashing, which in most code bases, it will just do that. And we caught on before that our interjection would be a highly skewed column. It noticed that as well. So we'll give it some credit there. So going into the actual notebook that the ML tool made for us, it also noticed in one of the columns that it said in the warnings, the profile is larger than 1,000 columns. We do not want to risk running out of memory during your profiling. So we're going to limit how many rows we profile, which would make it look different from the one we generated before. But since it made this notebook for us, you can come in and change that to ensure it's doing everything for you. So that was the change made here. You just come in here, comment out that, and it will not filter your data. But by default, it might. So that might affect the results that you see. And then we covered the semantic types. So let's get into that in just a second. Now, first, we're going to note that when it does its profiling, Databricks AutoML uses pandas profiling, which, by the way, is a deprecated library, been replaced by Y-data profiling. They will likely change that at some point, but for now, that is what is being used. And it's actually a pretty useful tool if you don't have a standardized profiling practice at your organization. This might be a good tool to use for what it offers. So you provide it what it needs. It will also give you alerts in the form of what it's noticing about your data. There's a quick overview showing some summary statistics. And you can come down here and look at, jump to any particular column you want to. We'll go to our interjections. Those were popular for a second. Let's see, did we lose it? Let's see. There was an error that was caught. Okay, well, we don't have a cluster running, so we're not going to look at that. But I can quickly explain why data profiling. What the tool will allow you to do is kind of look at different distributions of every individual column, what words pop up. It's a pretty useful tool when it's actually working, and you have a cluster running to kind of keep it going. And if you use Databricks AutoML, if you do not have one, it provides you how to get that up and running for you. And so it could be something that you can just run AutoML and have a tool at your disposal to start integrating into your practice that it gives you just for basically trying it out. But we'll jump from there into the actual modeling aspect. Now, what we did not get to see that I wanted to show you was that the profiling tool, it made note in the warnings that we were looking at categoricals for all of our columns, but it still profiled each one of those as integers very similarly to how the Databricks profiling tool did. Now, it made note of that, but it also kept them, I believe, as Booleans when it came to the actual modeling. So it modeled it one way, it profiled it another way. Whether it's a problem will be up to the individual people using the model, but it is worth noting that it does not tell you that up front if you don't know to look for it. Now, in the actual training itself, similar to the profiling, you can come in and change certain things that you do not like or do not agree with. And there are some choices that we made ahead of making our model that it wouldn't change. So we missed discussing this earlier, but since nouns were the predominant part of speech in our model, we wanted to assume that to be our base case. So to do that, we removed that column from the data so that modeling will not know to make a special case in trying to understand how your data structure is going to be made. But if we look at the data, uh, Databricks cell 16, let's see, we will notice that may have moved. Let's find it again. What we're essentially trying to get at here is in deciding to do one hot encoding for our categoricals, it decided it wanted to make a base case, which is a good move, but we'd already created our own. And so if we let it do that, we're actually having a data leakage problem because it did not know we did not want it to do that. So we have to basically manually come in, tell it not to drop another leading column so that we keep our data in the format we wanted it to. We also do not want to, in a classification algorithm, use the dates as a training feature. So we had to kind of come in here and modify this code to drop that column from the training data so that it would not do that. And we make the modifications throughout. And if you're not a trained data scientist and you don't know what type of model you're looking for, you may not catch that, but AutoML will attempt to do these things for you. But to also give it credit for the feature hashing. All basically said to say, to get the most out of this feature, it's a good starting point. It can also serve to help explain how to get these type of these training notebooks going. But you will still want to train data scientists to kind of come in and ensure you're getting the most bang for your buck in running these processes. So there are some imputation steps that it's going to try to do. We take those out because we already know our data is pretty much clean there. Running through the actual training aspects of it. And the AutoML notebook, the ones they generate, they do more than just train your model. They will show you what features it used. This is a hyperparameter settings that it applied to the model. It's good to know that. How it chooses those is a bit of a black box because every single model that generates will have its own set. But you can come in here and expand your search space manually if you are so inclined and trained to do so. Now, it also by default will include a SHAP, which is a way to understand feature importance and try to figure out how your models make them more explainable. But by default, this flag is set to false though. So when this notebook is generated, you have to come into this training notebook, set SHAP to true, rerun everything, and there it will generate your feature importance for you. So the way it's essentially working here is it's taking an entry from our data set, comparing it against the model results, and it's saying, hey, it seems like the lemmatized word column for both of your categories is most impactful for what your prediction value will be, followed by proper nouns, add positions, et cetera, all the way down to interjections, which have the least impact, which makes sense being a heavily skewed column. So this helps make your models a little more explainable so you can get an idea of what you may need to do to bring some of your performance back in line. Now, beyond that, it goes the extra mile to give you some examples of how to do model registry at the code level and perform inference on your models. And then it also shows you some of the results from its evaluation of the model that it just trained. So here we're looking at a confusion matrix, which tell us how the predictions went. So your true positives and your false negatives and all that, and how they compare with the predictions are shown here. And all these are recorded as MLflow object, by the way, for those curious. And then our ROC curves, et cetera, et cetera. So this will help us kind of get some preliminary models set up. Where these are stored is going to be in the experiments UI, which we will check that a bit later. But what we're going to care about immediately following this is the idea that we have a potential model that pre-AutoML helped us find. Now we want to maybe do some tuning on it, maybe make that the model we put into the process of getting to production, make some changes to it. And there are two different tools you can opt to make your primary option to go to do that within Databricks, and that will be Feature Store and then ML Flow. So we're going to do one at a time. Here we will start with Databricks Feature Store. So you saw us use that a bit earlier, but in essence, if you want to understand feature store at a very high level, it's you take the data features and the data itself that you want to perform training on, you put that in a separate table so that no updates to your actual data set will interfere with it or throw it off. And anybody that wants to come back and use this feature store will have a consistent set to use and a consistent set of features. And if they just pull in this particular feature store, they don't have to go and check it and see like what columns are used. It'll pull all that information in for you, and everyone on your team can work with a consistent set of information. Let's see. So this is what the feature store UI will look like. There will be some context changing for Unity Catalog just below this, but we can see here the primary key that we selected. Let's see, we have a description, we have where this actual feature store was produced, and for every individual feature in that feature store, we can look at the models it was applied to, the data type, notebooks where it's being used, etc. So a lot of ways to track where these features are actually being implemented. Now, if you decide to write to Unity Catalog Feature Store, as we showed earlier, this is not the UI you will be using to look at your feature store. It will instead go to Unity Catalog. So you will go to the actual feature store UI. We will click the feature store table that we care about, and we'll be transported to the Catalog Explorer, where we will then see a lot of the same information but presented in a different format. And so if someone is not familiar with being in Workspace Databricks versus Unity Catalog, that would explain why you get a jump in some instances versus others. So just wanted to make that clear. So here we want to look at some of the feature store clients methods, which help us to do everything we want to do programmatically. Most of these we're not going to dig too deep into. A lot of the naming conventions are a bit by the book, but there is a feature that's kind of on the horizon that I did want to make known. So here, when we're logging our models and saving them, there are experimental feature currently known as infer input example. So this is something that we'll notice is a little more fleshed out on the ML flow side of things, which may be worth knowing if you're trying to decide to use this or the procedure we're going to discuss in the next notebook. But this is currently experimental, which means it may not last, but we will see. So we're going to import our libraries, retrieve our model, and this is all going to be done using the feature store client. So we're instantiating it here as FS. Now we're going to read our table, provide it the name, and drop a particular column we don't care about, still within the feature store API. So then we're going to build out our feature table. And this will include some engineering we're going to do on the columns essentially to let me kind of rephrase this. So when we did AutoML, it picked up on the fact that our words were not numbers. So in our own models, now that it did the benefit of helping us do that, we need to make sure to catch that when we're generating our own features. That's essentially what this function is doing, is converting our words into numbers so that the math can be run on those. So once we get that, now we have the data set that we are going to do our training on. So we create a separate feature store for that specific set of features. So we no longer need to do these transformations again in a future instance. They're already stored that way. So here we move on to creating our trainer set, doing the chestain split. This is all, and we pick up our features using the feature lookup function, which is also a part of feature store client. So maybe we're jumping around a little bit trying to get past this technical part. We're kind of get more into ML ops. So if some of this stuff is cut short and you want to kind of dig deeper, be sure to pose your questions for a bit later. But getting more to the operations part, we're going to start our ML flow run, and we're going to use feature store to log our model. And we'll see once again, we're doing that infer input example here, even though we've created none during the training process. So what that would hopefully do is when it writes your ML flow object model, it will store as an attribute of the ML flow object an input example in JSON format. which you will in later instances be able to pull down and test your deployed model on. Um, and it'll also use that input example to infer what it thinks the schema will need to be, so long as this model is being used in the Databricks feature store client. And then we have an example of how to run batch inference once we've trained that model. So you'll need that model's name. It'll be stored here with the version number that's created. The initial one should just be a one. You communicate the result type, and that will help you run batch inference. So we'll go to a bit of a deeper process using the ML Flow API, but this is just one path you can go down. And we're going to see with ML Flow, with very minimal code changes, you can jump back and forth between one or the other, but there are impacts from your choice. So to not be glib about ML Flow, for those not familiar with ML Flow, it is an open source platform known for a lot of their abilities to help you track your models, track your metrics, and parameters. There's a model registry and model serving aspects of it. And a lot of those things are wrapped into a managed version within Databricks. So Databricks does use quite a bit of ML Flow under the hood, and it probably also taps into Databricks Feature Store as well. So we're looking at some small code differences between the feature store client and the ML flow client. So here we're reading in our data table, whereas feature store, you just need to provide that table name and it takes care of that. If you're not using feature store and your data is stored there, you'll have to manually pull from that table and either select star or all the columns that you want. Minimal change, just showing that your feature store really is just a delta table that is managed. And I don't think I put this in the notes, but it's worth noting that within the Unity catalog environment, a change has been made so that any table that has a primary key can be operated as a feature store. Now, feature store within Unity catalog is in public preview, so just wanted to make that known in case things change down the line, perhaps. Let's see. So it's still 2 lines of code to create your training set. One difference is that if you use feature store client, your log model ability, if you provide a registered model name, it will take the initiative and register your model for you. Within Databricks, ML Flow client does not do that. There's a separate line for evaluating your model and then registering it. So that's 2 lines. And then also the feature store, since it has everything wrapped into it, you just need to provide the model URI and the data frame and what you want out of it. And score batch feature will generate your inferences for you. Versus ML Flow client, there's different ways to do it, but you will need to pull in that model first before you can run any inference on it. So we'll see that below, but this was just a quick way to kind of do a comparison, one-to-one with what you see in the Databricks feature store API. So once again, retrieve our data from modeling. We covered a bit of these steps earlier, building your feature store, etc. The only difference is you still need the feature store client to create the feature store table. That way, you can also now manually write it and give it a primary key. But outside of that, you may not need to touch the feature store client at all if ML Flow is the direction that you decide to go. So familiar code here. And so when we're training our model, now we made inference before that the Databricks client allows you to infer your input example. Here, we're creating our input example by taking an example from our training set. And when we decide to log our model, we're providing that and passing that. So that will provide the input example that will be stored as a ML flow attribute inside the actual thing. Now, we're going to get into what that means in contrast to actually providing a schema, because they are not the same thing. It'll be very easy to get them confused based on what will actually happen later. But once again, we've trained our model. We're going to use a separate line of code to log it. And this will store everything inside the Databricks workspace model registry. Now, if you remember, we're also going to have different contexts for operating within Unity Catalog. So we're going to get that in just a bit, but also using this model, we're showing how to use ML Flow to do batch inference here. So you're going to need to use that model URI to pull it in and then run predictions on it once you've retrieved it. We see our first batch of inferences there, mostly articles. And you can do the same thing with Spark data frames or Pandas data frames. So we're just giving code to show that you can do either one. And here's the format being returned in a Spark data frame. Now, model signatures. We were just talking about this. So for those unaware, a model signature is essentially it essentially defines your input, your output, and your parameter schemas, and it logs those to ensure that when you put it out for deployment, anything that tries to invoke it will be conforming to what it's expecting. So it helps, and it also logs what it looks like. So in the event that someone does not know what to be doing with the model, it provides a way to kind of jump in and quickly learn what it's expecting. Now, we're assuming we're doing this after the fact, since we did not put a signature in when we created the model. We're actually pulling it back in a later instance to be able to do that. So it's not too late if you missed it when you first trained your model. You will just need to kind of come in here and recreate the training environment in which it was made. And we're pulling all these model dependencies from what was stored inside of the MLflow object model. And we will look at that shortly so you know what we're talking about. And so we're retrieving the model here and re-getting some of those parameters that were consistent from the training, recreating the training set. And this is being done so that we can run our predictions in this. And we're going to use mlflow.models.setSignature to attach that signature to the actual to the model that we had. Now, this is all still being done uh, registering the model here. This is all still being done in Workspace Databricks. Now we want to make sure we're giving you the context to do this in Unity Catalog. Uh, so you'll need to make sure you have the most recent version of MLflow installed. And then you'll need to do this programmatically by setting this here. So by default, the UI and MLflow at the library, it will attempt to write everything to the Databricks workspace area. This is telling us that we want to actually deal with Unity Catalog so that when you attempt to write using the catalog name, it knows not to look for Hive Metastore. So if you do not run this line, your code will fail. That is worth knowing. It has to be told we're operating within Unity Catalog and not Workspace Databricks. So that's what all this is for. So some of these options, just to kind of recap, for adding model signatures, for labeling your input example and doing all that, those options are available to you with the MLflow path. The Databricks feature store path is experimenting with that, but it's not a quote unquote native feature at the moment. So if that's important to you, we're just kind of educating you about that context. But now, next, as promised, to show you the MLflow object we were just talking about, this is what it looks like in the experiments page of the actual MLflow objects that were created for the models that we just trained. This is kind of a lot of the high-level information about how to make predictions on it. But the actual input example is stored here, as we mentioned, as a JSON file. So it shows us these are the columns. There's about 1,000 or so here, so it's a bit of a scrolling job. But the values in there, etc., that's what it looks like. And as far as the actual schema or the signature, that is applied here. So we're seeing that we know what inputs look like, what types we're expecting, the names of these columns, and what your output looks like. So these will be missing if you do not apply a signature. And when Databricks Feature Store tries to do this, it will use your input example to infer this information. But if you just do a signature, you will not have the input example. That's what makes these different. So just worth knowing. So now we're going to move on to what Databricks allows you to do using the UI to do these things. Now, quick context, once again, when using Unity Catalog, a lot of the UI features are not there. It's still being integrated with some things because they're a public preview. So this would be for workspace Databricks as before. So once you have your experiments trained, you can go inside here. And there's a couple of actually interesting tools that the experiments UI gives you. So let's talk through some of those first, actually. So once AutoML, which is one version of an experiment, gets done training a bunch of your models, it's just a set of notebooks under an experiment name. So if you do the same thing within your own notebook and you generate a bunch of experiments, creating your own models, it will just have the experiment under that notebook's name, which we're seeing here, AutoML modeling. So every model that you train and you log will be showing up in this experiments table, and you can compare these using this table view. So we have our metrics that we use. We brought in classifier learning rate, but you can also look at what type of model did it create, things of that nature, and compare based on that using the table view alternative. And then you can also, of course, delete some of these that are not useful, change the colorful names if they don't prove very informative for you. All those things can be done for sorting. And then beyond that, there is the chart view. Oh, I'm sorry, this isn't the chart view yet, the comparison view, which is you click a couple of check boxes here and you click compare. We'll start off with just two. And in this screen, you will be able to look at the different run details, compare the parameters between runs to see which model is doing kind of what you like better. You can generate different visualizations with a couple of drop downs to see how these are working out, based on your end value that you care about. So that's a way to quickly compare two models and get a lot of deep detail about them. Now, if you want to compare hundreds or maybe more models, you can go into the chart view. Now, in this chart view, it's very similar to compare, but now it's operating on the scale of all the models it can get its hands on. And so you can kind of quickly look at where things have been going with your training experiments. So same view we noticed before, this chart here is looking at your different parameters and how they're leading to your ultimate test recall score in this scenario. Or we can put things on a scatter chart and look at where our accuracy is landing for different types of models and maybe use that to kind of filter out where we're caring to look at. And I believe on this side, you can actually check certain models off. If you know that where this lands doesn't matter to me, because it's not useful information, it's not a good model. Or you can just delete it outright if you don't care for the notebooks. But once you find the one you care about, once you've gone through all this process of eliminating the ones that are useful or useless, and you identify the ones that are useful, you can click on any particular model, and you will go to its page, as we showed earlier, the MLflogic page, and you will be able to find the register model button. This is all reminder being done in the UI. And so once you do that, all you need to do is supply a model name, tell it to create your new model, and now in your registered model page, it will show up here under version 1. If it is your first time doing it, if it is the same name of an existing model, your old model will not be lost. It will simply increment the latest version and let you know, there's more than one model being filed under this name. And I believe that covers most of us for the model registry. I don't think we're missing anything, but if we do, I will wrap back around. If you have questions, definitely add them and we will come back to it. But um, now we're going to move on to actual model deployment. So now we're at the phase where we have a model that we've chosen. We've a model that we like. We want to start moving it closer and closer to production so it can begin that journey. And this is where it can get very different depending on where your organization's maturity level is, what your standards are when it comes to data practice. There are a lot of things that will inform your model deployment pattern, and those patterns being primarily deploy code or deploy models and everything in between there. So these will factor in expertise. These will factor in your data policies, what the costs will be, how your models are functioning, and how you're storing them. All these considerations will need to be a conversation, but ultimately you're going to fall somewhere within this range. So as one small idea, perhaps you do not have production data available to train your model on in your development environment, right? Something like that will affect which deployment pattern or all variables you go with. Maybe your models are very heavy and they take a long time to train. Maybe you're Google and your model takes a week to train, right? And you don't want to train it once in dev and then move it to staging and train it again. So because it's delaying how long it's going to take you to get your model out. So at scales like that, that will also determine, actual cost and then market cost and opportunity cost, what your decision will be. All basically just being said to say this can be a very involved decision. But let's not get too down in the weeds with that. But we're going to be in this instance providing a model deployment, I should say deploy code model, I should say. So when we're moving our models from development and transitioning to staging or production, within Databricks, you can go to the actual model itself and promote it using this icon here. And this kind of tags the model / labels it. So you can kind of come in and check where everything's at if you're new to the team, new to the process. All this will be documented within the UI. You can even add comments to ensure that you know what reason you promoted things for or what concerns you may have. That's the UI option. We quickly note here, there's actually also an ML flow line of code to be able to do the same thing. So we can put your level, your version number, your description, the name, etc. So you can have options to do that. But when going the UI route and you tell Databricks, hey, I go into my model, I want to get this model prepared and using for inference now. You have three options of how you want to deploy your model. You're either going to be doing um, real-time inference, or you're going to be doing batch inference or streaming. I know we're low on time, so we're kind of going to jump through this a little bit quickly so we can make sure everything gets kind of communicated here. But if you tell it you want to do batch, it will create a notebook for you that will show you how to do all that. We saw some of that also in the ML Flow object model. And this is some of the example code that it provides for us to do that. So it's just recreating the environment and then pulling in the model and doing it. We've seen some of that before. Similarly, if you do streaming, it will do mostly the same thing, but streaming uses Delta Live tables, which is used for your data consistently coming in, and your inferences will be done a little bit differently there. And here's model code to pull that off. Now, real-time inference uses Databricks serverless. It's this model serving feature requires the premium account tier to do, and a little bit of setup, but it offers a low latency, scalable option to use if you want to have things be able to be called from a serving endpoint. So here we're just showing you how to create said endpoint. You can do it via the UI, which is just choosing your model, the version number, and click create serving. Give it some time to get that endpoint going. And then as you start using it, it will generate statistics for you to look at how it's performing. And you can generate more than one model per serving endpoint. You can direct how that traffic flows and percentage, and then you'll get to watch all that in real time as the API gets called. So this is an example of what the API request looks like once your model is up for serving. You'll just need to build an HTTP post request to be able to invoke that. And you'll need to know, well, you need a Databricks access token, which is out of the context for explaining, but you also need to provide the location of your model, which will be in your Databricks environment. We don't want to expose all that here clearly, so we've wrapped some code around that and shown it being done for our particular environment over here at Blueprint. And you can see we've run on a data set in Unity catalog here, and we run our prediction, and we got back an article from the training example that we use. So if you think back to that training example that we input, I'm actually using this code here to pull that in and then run inference on that. I didn't have to go anywhere and make my own training example to run on. But a little bit about deployment, just a few minutes left before we want to get to any questions that may be presented. And now we're going to get to monitoring. So your data model or your machine learning model, I should say, has been created. You've stored it, you've pushed it to production, it's live and running in the world, right? But it'll only be a matter of time before either the world changes or your data changes and your model is no longer performing as good as you want it to. You may even run into that as soon as your model goes out. It may crash and burn immediately, but you'll want to know why and figure that out. But if it happens to last more long term, drift could be the reason that your model is not ready. And the two types of drift we care about are model drift and data drift. And you can think of model drift as concept drift in a nutshell. You can think of it as I'm trying to figure out what the projected local gas consumption expectations are in my community, but now EVs are everywhere. So your data could be fine, but the concept in the world in which your model operates has changed. So now your model may not be any good. You just need to account for that now when you build your new one. Or perhaps, customers' behaviors are changing and your statistics are being skewed, and maybe your model is heavily dependent on that. You want to know that's going on before you try to assess why your model is not performing well. So that's a quick high level understanding of what drift is. What you want to do about that is monitor it, which will help inform you when to retrain your model. So there's different ways of doing that. Just for the sake of making it kind of easy to digest, this is the visualization tracking a lot of information about our data. So we're seeing month to month how much our data is growing by. And these lines are telling us around what percentage something sits at for our parts of speech, as well as how much is articles versus ads. Not much is changing, so we're in pretty good shape here. But if we wanted to install a modeling function to test that for us, it's like, hey, we quickly built one. check for anything that's exceeding a 5% threshold change. Nothing there. You can get a little more granular. And we've noticed that the number of ads has gone up by 1.3% in our last check of our data. So you can do that however you want to, but one recommendation is to make sure these are being written to tables, your predictions and your monitoring information, and build dashboards in Databricks SQL to help you quickly visualize these so you can know, maybe get a heads up about your data on its way to change before your model completely goes broke. So I think that takes us from end to end. We've taken our data set, got it in production. Now we're monitoring it. I believe that's all the time we have for now, and we'll be adding more context in future installments as well. So this one mostly focused on getting unique catalog brought into things, showing you how that works, and we'll have some talks about even figure out what new parts we want to bring in later. So hopefully this was useful to you, and I'll pass it back over to Ruthie or any questions you guys may have, and thank you for your time.
Awesome. Thank you so much, Adrian. That was extremely informative, and we got some great comments just mentioning how great this is and thanking you for presenting. So great job, and we really appreciate it. I just wanted to say if anyone has any comments, feel free to add them into I should say questions. You can add them into the comments section. And if you have any further questions that you'd like answered, you can always email us at info@bpcs.com and we will connect with you. We do have a really great lineup of more events coming up. The next one is going to be next Wednesday, and that will be, let me see, on the topic of data sharing and marketplace. If you'd like to attend that one, hop onto our LinkedIn page and we will be sure to, and you can register there, and we will be really excited to have you on that one as well. It's going to be really great, put on by Eric Vogelpohl. If you haven't heard him speak before, you are not going to want to miss this one. So we are excited for all of the lineup that we have coming up. Don't forget to sign up for our expo coming up on October 3rd as well. All of this information is found on our website at bpcs.com. Thank you everyone so much again for joining. And let me just double check that we don't have any more questions. Nope, nothing else. So thank you everyone for joining, and we appreciate you taking your time out to join this workshop, and big thank you to Adrian for putting this together. We hope to see you all on our next one. Have a great day.
Thanks, people.